5 years ago, this already happened. While the world argued about what might come next, an American fighter was already flying faster than anything designed to fight. Faster than doctrine allowed. Faster than adversaries believed possible. Faster than most analysts even considered necessary. No rollout, no footage, no warning. By the time rivals realized they were behind, the gap was no longer closing. It was permanent. Because the F-47 didn't arrive in 2025. It arrived years earlier, and it changed the air war before anyone noticed. The United States Air Force didn't just cross another performance milestone. It quietly erased a boundary many engineers believed could never be crossed. While China and Russia rushed to close the gap with fifth-generation fighters, America moved several steps beyond them, out of sight, out of range, and out of reach. For nearly 5 years, an aircraft flew in darkness, breaking records no one was allowed to talk about. No press releases, no satellite photos, no congressional hearings with open microphones, no confirmation that it even existed. And there was a reason for that secrecy. Because over the Pacific, a new threat was taking shape. One that forced the Air Force to abandon every rule of speed, stealth, and survivability it once believed was unbreakable. A threat that could not be answered by incremental upgrades or legacy platforms. A threat that demanded a clean break from the past. To understand how the F-47 became possible, you have to understand why those rules failed. Only now are we learning what was already in the air. The F-47 didn't suddenly appear. It didn't roll out to applause or debut at an air show. It didn't arrive with a press kit or a slogan. It arrived silently, already dominant. And what you're about to discover doesn't just redefine air superiority. It forces a complete rethink of how modern wars will be fought, how airspace will be controlled, and how quickly conflicts may now be decided. But before we talk about how fast this aircraft really is, you need to understand why the Air Force buried this program so deeply that even senior lawmakers barely knew it existed, and why a growing threat over the Pacific made that secrecy unavoidable. Welcome to Jet Intelligence, where we break down the technology shaping global power. Today's story isn't just about a fighter jet. It's about a leap so large that America's adversaries are still trying to figure out what just happened. If you believe the United States must always lead in the skies, type proud in the comments. The secret flights. In March 2025, President Donald Trump stepped to a podium and dropped a revelation that rippled through defense circles worldwide. The F-47 was not a concept. It was not a rendering. It was not a prototype. It was real. It was flying. And it had already been breaking classified performance records since 2020. For nearly half a decade, experimental versions of the aircraft had been conducting secret test flights. Hundreds of hours of real-world flying, not simulations, not wind tunnel models. These flights weren't about impressing anyone. They were about validating physics at the edge of survivability. Every sortie answered questions aerospace engineers had wrestled with for decades. Could speed and stealth finally coexist without compromise? Could an aircraft remain survivable at sustained supersonic velocities inside modern integrated air defense networks? And could it do so repeatedly, reliably, and operationally? Not once under perfect conditions? While analysts debated what sixth generation might someday look like, American industry was already proving it in the air. These were not early fighter prototypes. They were X-plane demonstrators, purpose-built experimental platforms designed to shatter assumptions, not impress audiences. And shatter them they did. In September 2020, DARPA quietly confirmed that its demonstrators had broken records. No footage, no numbers, no explanation of which records, only confirmation that something unprecedented had occurred. That silence was intentional, because revealing the achievement would have revealed the vulnerability it exploited. The speed barrier problem. For decades, fighter designers ran into the same wall. If you wanted extreme speed, you paid for it in heat. If you wanted stealth, you sacrificed speed and endurance. At Mach 2 and beyond, friction alone generates surface temperatures that destroy traditional radar-absorbent materials. Infrared sensors flare instantly, engines glow, exhaust plumes stretch for miles. The aircraft becomes visible long before it becomes lethal. That's why stealth fighters traditionally cruise subsonic. That's why raw speed belonged to aircraft like the SR-71. Fast, but not stealthy, and not fighters. The F-22 Raptor pushed the boundary, topping out around Mach 2.25. The F-35 prioritized flexibility, maxing out around Mach 1.6. Both were revolutionary. Both defined an era. Both are now eclipsed because the F-47 didn't choose between speed and stealth. It chose both and accepted none of the traditional penalties. What makes the F-47 different? The F-47's publicly hinted performance reads like science fiction. Sustained Mach 2 plus capability while remaining stealth dominant across multiple sensor domains. Industry insiders quietly suggest Mach 2.25 is merely the baseline, not the ceiling. But speed alone isn't the revolution. The revolution is maintaining that speed without lighting up the battle space, without announcing presence, and without degrading survivability. That required breakthroughs not just in aerodynamics, but in materials science, propulsion, thermal management, and systems integration. Each solved problem introduced new constraints. Each constraint demanded new solutions. And that brings us to what the Air Force calls Stealth++. Stealth, rewritten. Every aircraft emits signatures. Radar reflections, infrared heat, electronic emissions, even subtle disturbances in air molecules detectable by advanced sensors. 5th-generation aircraft reduce those signatures. 6th-generation aircraft aim to make them operationally irrelevant. At the heart of the F-47's leap is a ceramic-based radar-absorbing material developed through classified partnerships with American research institutions. Unlike traditional polymer coatings, essentially advanced plastics, this ceramic material is resistant to extreme heat, impervious to rain and salt spray, hard enough to withstand sand abrasion, stable during sustained supersonic flight. It absorbs more than 90% of incoming radar energy, while remaining effective at temperatures that would destroy earlier stealth coatings. This single breakthrough changes everything. It allows the F-47 to sprint toward 1,700 miles per hour into heavily defended airspace, while remaining nearly invisible across radar and infrared bands. By the time enemy sensors register anything unusual, the engagement is already over, and the aircraft is already leaving. Range, the silent advantage. Speed and stealth mean nothing without reach. The F-47's combat radius exceeds 1,000 nautical miles, nearly double that of the F-22. That means deeper penetration, fewer tankers, and vastly more operational flexibility across the Pacific. In that theater, distance is not a detail. It is the primary constraint. China's anti-access strategy relies on pushing American forces outward, stretching supply lines, exhausting tanker fleets, and forcing predictable approach corridors. The F-47 ignores that logic entirely. From bases in Guam or Japan, it can reach deep into contested airspace, execute its mission, and return, often without tanker support. That isn't incremental improvement. It's a fundamental shift in power projection. Why speed still matters. Speed in modern combat isn't about showing off, it's about energy dominance. A missile launched from a fighter already traveling at Mach 2 carries enormous kinetic advantage. It flies farther, it accelerates faster, and it gives the target almost no time to react or reposition. But there's another advantage: escape. When missions go wrong, speed becomes survival. Most enemy fighters cannot intercept a sustained Mach 2 plus aircraft. Many missiles can't either. Speed becomes defense. And the F-47 doesn't rely on afterburners to do it. Supercruise perfected. Afterburners create massive infrared signatures and burn fuel at staggering rates. They're useful, but brief. The F-47 can supercruise, maintaining supersonic speed without afterburners through most of its mission profile. That means lower infrared visibility, longer range, sustained speed during penetration and egress. A typical mission looks like this: takeoff, accelerate to supersonic cruise, penetrate hundreds of miles into hostile airspace, engage targets, exit at speed, still stealthy. The enemy never gets a clean shot. And this isn't theory. The X-plane demonstrators proved it years ago. The force multiplier, loyal wingmen. But the F-47 doesn't fight alone. Its true power emerges when paired with collaborative combat aircraft, AI-controlled loyal wingmen. These are not remote-controlled drones. They are autonomous combat aircraft with sensors, weapons, and decision-making systems capable of independent action within commander-defined intent. The F-47 pilot commands them like a battlefield commander, assigning roles while the AI executes tactics in real time. A single F-47 may operate with 5 or 6 wingmen. Together, they create distributed sensor networks, electronic warfare screens, missile sponges, strike extensions. If drones are lost, pilots are not. This changes everything about risk, scale, and survivability. The Air Force plans to acquire over 1,000 collaborative aircraft to support roughly 185 F-47s. Each manned fighter becomes the nucleus of a combat system that once required dozens of aircraft. The strategic shock. Did the F-47 break speed records? Yes, but not in the way the public imagines. The SR-71 still holds raw speed records, but it wasn't a fighter, it wasn't stealthy, and it wasn't survivable in modern airspace. The F-47 set a new benchmark, the fastest stealth combat aircraft ever flown, at operational range with weapons and with survivability. That combination had never existed before. China and Russia are years behind. While competitors revealed renderings and concept art, America flew classified demonstrators. That head start may prove decisive for decades. Why this matters. Air superiority isn't optional. Without it, ground forces stall. Naval forces retreat. Power projection collapses. The F-47 ensures that doesn't happen. In any Pacific scenario, it can penetrate advanced defenses, clear airspace, enable follow-on forces, return safely. No other aircraft on Earth can currently claim that. From secret to reality, the first production F-47 is already under construction. First flight is planned for 2028. Operational capability follows by 2029 to 2030. That speed is unheard of because the technology was already proven. Boeing invested billions in production facilities before the contract was even awarded. They knew what their demonstrators had achieved. They knew there was no alternative. The final word. The F-47 didn't just break speed barriers. It shattered the assumption that America's technological edge was fading. It proved that when properly funded and focused, U.S. innovation still leads the world, quietly, decisively, and ahead of everyone else. By the end of this decade, the F-47 will patrol the skies with capabilities no rival can match. And when it does, the balance of air power will already be settled. If you found this breakdown valuable, like the video and subscribe to Jet Intelligence. Because the most important revolutions in military aviation don't happen in public. They happen in silence, until it's too late to catch up. Stay proud of what American innovation continues to achieve.